The Earth is home to roughly 7 billion people with diverse cultures and languages. But despite our differences, we are all linked by business. We all eat, shop, and dream of owning something. And most of us work. All businesses must have supervisors to function. Supervisors oversee the work of others to accomplish the objectives of the business. They represent both management to the workers and the workers to management. Welcome to SuperVision. I'm Gemmy Allen, and I'll be your guide through this SuperVision class. Welcome to SuperVision Lesson 3, Problem Solving by Turning Setbacks into Comebacks. A well-known saying among coaches goes, "Winning isn't everything, it's the only thing." The truth is, there is never an only thing. Setbacks come because of problems. So solving problems plays an important role in almost every athletic competition. When the team is losing, adjustments must be made. The environment must be analyzed. The opponent's weaknesses must be evaluated and exploited. Then, a setback is nothing but a setup for a comeback. The wisdom in these words can help lift low points and put the team on the path to victory. Supervisors constantly make decisions that affect the work of others. Day-to-day situations involving supervisory decisions include employee morale, the allocation of effort, the materials used on the job, and the coordination of schedules and work areas. The supervisor must recognize problems, make a decision, initiate an action, and evaluate the results. In order to make decisions that are consistent with the overall goals of the organization, supervisors use guidelines set by top management. Thus, good planning leads to solving problems and making good decisions. A standard is our best current method of doing our job, but it is meant to continually change as we discover better ways of doing our work. A problem is a deviation from a standard. It is the gap between what should be happening and what's actually happening. Supervisors want to involve as many employees as possible in problem solving, asking why the problem exists. All people are creative and can apply their creative ability to solving problems. Some people are creative in making associations, such as combining things to bring about certain results. Others are creative in forming new objects and/or ideas, such as taking resources and constructing a building without a written set of plans. Still others are most creative in helping people and organizations become more effective. Creative problem solvers apply their energies to determining new ways to perform a task, to make a product, to meet a consumer need, to increase return on investment, or to resolve differences among people. Supervisors can set an example for employees by using their own creative ability. This means looking at a situation from different perspectives and thinking about ways to improve performance. But creativity doesn't happen when we are trying to be creative. Creative thinking occurs most often when we step back and get a bigger picture of what's happening. Sometimes our best ideas come when we're completely detached from the problem we're trying to solve. Playing golf, going for a walk, taking a shower. All of these activities take our minds off the immediate problem and give our creative thinking abilities a chance to operate. Employees need to be encouraged through recognition and rewards if we expect them to apply their abilities to help solve problems in their jobs and in the department. The causes of the problem invariably fall into one of three categories: inadequate standard, inadequate adherence to standard, or inadequate system. The following scenario may seem old, but the information is still relevant today. Use it to model your own philosophy of management.
Phil, the only thing I can think of offhand is to process that order at the end of the shift. I mean, it's the logical thing to do.
Well, what's that going to do to your costs, Jim? I don't want to see this thing hurt your record.
Won't Mr. Greenberg understand? I mean, he knows costs will be high.
There's got to be another solution. Now, how about looking at it some more?
Okay. Maybe I just don't have all the information. Or maybe I overlook something. The projections appear to be right. Okay, what are my choices? Yep, the one that looks best is to run it after the shift, on overtime. No, that just won't do. The unit costs are unacceptable. Oh, time to get going. Bowling tonight at 5:15. Well, looks like I'll just make it. I need to sit on this thing for a while anyway. Maybe talk to some people, get some ideas.
Jim is becoming more aware that a conventional solution will not work, so he needs to let his creative side take over. Often, the easiest way to move from left to right side problem solving is to shift one's activities. Take a walk, take a shower, turn on the radio, the TV, or put on a record. Look out the window, or as Jim did, go bowling. Jim is in the beginning stages of the creative decision process. Here, he did the necessary first thing. He sized up the situation and the problem. He also began to do the second step, explore the possible solutions. When he goes bowling, he can put it in the back of his mind, letting it incubate and trigger a solution. Let's rejoin Jim.
I've really got to work on my game. Maybe it's my approach. Too darn many splits. Splits. Splits, that's it. How about splitting the workload? I never thought of that. It was right under my nose and I didn't see it. I can split up the assignment during the regular shift since the special run involves mostly Jane's and Bob's stations.
In organizations today, creative problem solving is often done in a group setting. To do this effectively, the group must be aware of the problem. The atmosphere must be open and non-judgmental. And there must be skilled leadership to facilitate and ensure results. Suppose you're leading a group solving session as Jim is doing with his quality discussion group. Once you identify the apparent problem, the first thing you'll want to do is what we call green lighting, where we set a free and open atmosphere and get on the floor and on the chalkboard any ideas people have in mind. The more the merrier.
So what's happening, as I understand it, is that heat buildup softens the solder on the panels just enough to affect the performance of the panels during testing. Now, is that a fair statement?
Yes.
Yeah?
Yes, correct.
Okay, let's first come up with ideas on this. Any and all ideas. And the ground rules are that we make no judgments or comments at this point.
Well, to start with, I think engineering specs are too lenient.
I agree with that.
Yeah, they are. Incidentally, even though we have some gripes with engineering and other units, let's first think about solving the problem.
Okay.
Well, how about a cooling period?
That's good.
Yeah, before testing. Also, temperature heat sinks for protection.
Or maybe tungsten wire. That can stand the heat. Yeah.
Tungsten wire, that's terrific.
Yeah. Mm-hmm.
Okay, now what else?
Yeah, okay.
If we use a tungsten wire, can we get that from our present suppliers? Yeah,
Well,
I think
yes.
we can. Okay,
Jim's next task is to form the ideas into a manageable list by combining items that go together, editing them for better understanding. We call this process yellow lighting. The caution light is on. We're starting to use judgment, leading to the final step, which involves red lighting, where we put on the brakes, prioritize the ideas, decide what's feasible, and arrive at a solution. Jim and his group will demonstrate yellow lighting and red lighting.
Hey, do you see any others we can combine?
No.
No? All right, then. Let's use this as our working list. Now, is everyone clear about each one of these and what they mean?
My only question is about temperature control. What's that all about?
What I meant was controlling the temperature in the whole process so the entire panel does not get hot.
Okay.
Any others? Okay. Now let's go to the next step. Now we're going to put on the brakes, so to speak, decide what's possible, and then what's the best solution. Let's do that in reverse order, though, so that we first come up with the best solution. That way, if we feel strongly about a solution that isn't practical right now, maybe we can find ways to make it work. Okay? Okay, I think that's about as far as we need to go. Now, it's clear that your #1 priority is better quality solder and then maybe the flux, followed by these other items. Offhand, I'd say that different materials would not be feasible. The company's committed to the present wire, though maybe we could change suppliers.
Temperature control is not very practical either, not in the test equipment anyway. We might as well get all new equipment.
Yeah.
But, you know, temporary heat sinks are possible, though.
Yeah, but it may be a pain inserting them, but it can be done.
What about our first priority? Feasible or not?
I think it is, but engineering might not. You know, this might be tied into that supplier thing. Maybe by changing suppliers, Jim.
Good idea. By doing #6, we might get #1 accomplished.
See there, Bob, not bad for someone who's always talking about being over the hill.
I think engineering would rather buy new solder than buy new test equipment.
I agree. It would be less complicated for them.
Right. From a budget standpoint, one's capital, the other's supplies. Anything else? Okay, then. I think that's about as far as we need to go. Now, I'm going to pass this on to Phil as a recommended solution. And I'll let you know how it goes.
There are 4 major decision-making processes. The routine approach is best when a matter is clearly covered by policies or rules which must be followed. The logical approach is the most widely used because of its relevance in many decision situations where alternatives must be weighed in relation to a known objective. Scientific method is most appropriate when a test or experiment is needed and alternatives can be systematically studied. When a situation does not lend itself to conventional solutions or when another perspective is needed, creative thinking is the best choice. In practice, several of these approaches may be combined. For example, scientific method and creative thinking are often used to explore and test alternatives under the logical approach. Thus, the approaches can be very compatible. When making decisions, supervisors must know priorities and follow them, define the problem accurately, and implement solutions effectively. You saw in this lesson of problem solving that good supervisors turn setbacks into comebacks. Successful supervisors acknowledge the difficulty and uncertainty of solving problems and making decisions. They are resilient and flexible and forgiving enough to handle errors. When mistakes are made, they have the ability to recover. It is not whether you make the right initial decision or not. It's how good you are at learning, adjusting, correcting, doing all the things you need to do better. In sports teams, you turn setbacks into comebacks. With this lesson, we've shown you problem solving by turning setbacks into comebacks. Try to relate what you read and discuss to your own real experiences at work, in the classroom, on the athletic field, and at home. Coming up in the 4th lesson, we'll start studying organizing. This has been SuperVision Lesson 3, Problem Solving by Turning Setbacks into Comebacks. I'm Gemmy Allen, and I look forward to guiding you each step of the way as you determine your own philosophy of management.